Hello, everyone. So you may have noticed my background change. I just moved, although the backlighting is still kind of an issue. Nonetheless, hopefully at some point a cat will jump up there because I know people like my cats. But we're on to the second day of teaching live online on Twitch. Um, as a request, while I'm doing the announcements, certainly go ahead and throw out any questions about course logistics. But once we actually get into the course topic, if you have a logistics question, just hold it till the end. I'll do a Q&A period at the end of lecture today. But with that, today we're going to be discussing stacks and queues. Later this week, we're going to be talking about algorithms, and stacks and queues is kind of a good intro to that topic. From there, homework 4, as a reminder, is due Friday. We will have office hours. It has been pushed back to Friday. Um, we will have office hours this week. Um, or sorry, it was next Wednesday. Apologies. Sorry, I'm getting my two classes confused. It is due next Wednesday. You are absolutely correct. Sorry, I have two classes and they both have a homework for, and you are absolutely correct. It is due next Wednesday, April 1. Sorry about that. Um, yeah, sorry. Everything going online has been a bit tricky, but with that, we will talk about the exam information, the review session, which is next Wednesday. Additionally, there is lab today and tomorrow, which relates to stacks and queues that you'll need to do. Remember that lab still counts towards course credit. You need to, as opposed to previously, you need to submit online on Colab your end solution. So the directions are there to help you out with that. Before I jump into the lecture, are there any questions? I'll go ahead and just give a minute for questions, otherwise I'll just jump right into it. Um, and I'm just taking a second to clear out the source code I have so far because I'm going to rewrite it. Our quiz is resuming this week. Yes, there will be a quiz Friday. There will also be, so people won't be particularly happy to hear this, my guess is, there will also be a quiz next Friday. Logistics questions are fine at this point. How does lab work again? So lab is going to be an assignment where you're allowed, it's open note, open, whatever you want, but you do have to work on it. You're not going to show it to a head TA, rather you're going to submit your end result on Colab. If you need help with lab, there is a Discord channel. Will lecture streams be posted on a YouTube channel? They are. Apparently, there is an issue last Friday where it didn't go up. So as always, I set up Twitch so that it saves my past broadcasts, so you can always check there. But I will be uploading them to YouTube. Yes. It should be there now. Last I checked, it was there. Let me take a look. I got it up. Yes, yes. No, it's not there. Huh. I'm gonna have to take a look at why it's not showing up because I've now uploaded it twice and YouTube is not telling me why it's not being. Huh. I will get to the bottom of that. YouTube. This is a technical issue with YouTube, but my past broadcast will always be on Twitch. If you go to the past broadcast channel, will still be on April 3rd? So the exam was already pushed back to April 3rd. So it was not originally on April 3rd until right before we came back from classes. We updated the schedule. Isn't there a recorded lab that we can view? If there should be, and we'll get the directions up for that on the Piazza Master thread. Um, is the due date of Monday Lab to be Tuesday night? Yes, so they're both going to be Tuesday midnight, and it's just because it's too much of a hassle to give one due date to half the students and one due date to other students. Yes, so it will be Tuesday at at 11:30 p.m. Eastern, of course. Um, So we will have the information up. For the first time, I'll make sure that we post on Piazza the lab recording link, and then we'll make sure it's on the master thread where the permanent location is. But it will be a recording. It will be pre-recorded. All right. Last chance to get a question in here while I'm just deleting my starter code. I've already uploaded, by the way, the finished product of everything I'm going to write today, so you can view that. Um, but in the meantime, I'm just going to delete my starter code. That way, we're all starting from scratch. All right. So today we are discussing stacks and queues, and we're going to start by differentiating the two. So the idea of a stack is it's first in, last out, and the idea of a queue is it's first in, first out. We'll sometimes say last in, first out, or first in, last out. Both are effectively the same. So queues are the most natural. They're easy to explain. A queue is like a line. So, if you've had to go to the grocery store or something over the last few days to get supplies, toilet paper, of course, assuming you can find it, you've had to wait in a line, right? And the first person who gets to the line is the first person served. And when you enter the line, you enter at the back and you wait until you cycle to the front to be removed from the line. That is a queue. A stack is a little bit different. So with a stack, rather than the first person entering the line being the first person out, FIFO, first in, first out, we instead have FILO, which is the first in is the last out. Let me show you an illustration, and hopefully this works. I'm blowing up chat so that way I can see if this visual quality is too poor, and if it is, I'll try to fix it. But in the meantime, I actually set up a whiteboard over here. So the idea, excuse me, there's a box in the way. The idea of a stack is, and I'll try to draw it down here so there's less glare. And please let me know if you can't see this. The idea of a stack is that as we insert elements, we insert them at the front. So let's say we start adding 8, 6, 7, 5, and we always insert in the first empty space. From there, and I apologize that my body is physically in the way of the camera. I'm just trying to keep an eye on chat at the same time. From there, by the way, this whiteboard I was already planning to put up for my own purposes. So it just conveniently works out here. So from there, when we insert the next number, say 3, we're going to insert it into the first empty space. So that is how we add elements. By the way, please actually post if the visual quality is too bad. I will try to do what I can to fix it. From there, when we remove, the element we remove is not the first element we added. This is where we added our first element. Rather, we're going to remove the last element added. So we're going to remove this element. Where'd my eraser go? Right here. So when we remove 3, now our last element instead becomes 5. Forgive me, I'm just reading chat. Okay, good. All right. So this is the idea. And then if we remove another element, we do the same thing. We remove 5, we move the last pointer. Remove another element, 7, we move the last pointer. Now, when I say a pointer, understand that this is not really any kind of, like, you may have seen pointers and say, like C, and that may panic you. Understand that all these actually are just ints. And the idea is they are the index of the array I'm looking at. So 0, 1, 2, 3, 4, 5. So at this point, first is always 0 in this stack. It's never going to change. So much so that we actually just don't even really need this variable to exist. And rather, we're going to think of last as the top of the stack. And so the way to visualize this is to visualize it bottom up. And you can think of it like this is like a little chute that we can drop numbers down and they fall to the bottom, to the first empty space. So 8, 6. If I push onto the stack, that adds an element onto the stack. Also, apologies if there are questions in chat. I actually can't see chat from here, so I'll come back to it in just a second. So if we were to push 7, you think of it as dropping 7. It falls down to the first empty spot. There we go. Now, when I want to remove a number from the stack, I reach my hand down, I grab that 7, and I pull it out because it's on the top. So again, same indexes, just bottom up. So 0, 1, 2, 3, 4. And my top is just going to be whatever number my index's last value is. So in this case, top is here. Are there any questions about that? Sorry, that looks kind of like it's pointing. What subject is this? This is CS 2110, Software Development Methods. So this is the idea of a stack, and we have it illustrated, as you can see in the... Oh, we have lost the camera. We have a cat attack. Stack it like a Pez dispenser? Yeah, kinda. Visually, it's not a horrible way to think of it. Sorry, I have to... Sorry, I'll fix the camera in just a second. The twisty part came loose, which I don't know what the twisty part is called. Okay, there we go. Sorry, we had a Stewart attack there. So this is a stack. The top points to the first empty index, not the last occupied one. So there's two ways to do it. You could have the top point either to the first empty space, at which point the top, in this case, would be 2. You could have that be how you program it, or, and this is equally valid, choice is yours, I could have, and I'll use my blue for this, top point to the last occupied space equals 1. The difference is, if I do this approach, where the top is the first empty space, my stack is empty when top is 0. If I do the first occupied space, the stack is empty when top is -1. So however I choose to implement it, I can make it work. It's up to me. Can we see Stuart? No, he ran off because he knew he did something bad. So there are two approaches. On this case, in the slide, as you mentioned, we're doing the first empty space. That's how we'll implement it with the code, but you can do it either way. Thank you for the T-Tours in chat. That is an apropos use of that meme. All right, so with that, let's go ahead and jump into some code. So the first thing we need to recognize is what are our fields. Well, we're going to, in this case, make a stack specifically of strings. So you can decide what the top is. It's up to you. You can implement it both ways. But in my code example, I'm actually going to do what is on the what is on the slides here, which is to say I'm going to do the top, in this case, be equal to 2. Otherwise, I could make top equal to 1. It's whether or not I want it to be the current top or the first empty space. Those are the kind of two choices, and you can make like a stack of plates, exactly. So if you've ever worked in a restaurant, you've probably seen those dish hoppers where you put a plate on top and the spring weighs it down, so that way all the dishes are in a protected sleeve. It's exactly like that. You can add dishes to the top. You can take dishes off the top. You can't take dishes off the middle. There's no means to do that. So from there, let's go ahead, jump into some code. So I have my stack object. And by the way, the end result of this code is already uploaded. We're just going to build it up incrementally over this class. So we're going to start with this variable called the stack, which is an array of strings. So we're implementing this as an array for now. And we're going to say the initial size is 3. That is to say, initially our stack will be size 3. As needed, we can increase the size. But let's start with just something fairly small. And then, exactly like pancakes as well. And then we're going to keep track of our top. So when we create the stack, the first thing we need to do is need to create our array. So we're going to create our array. The stack equals new string array, and we're not strong, string array, and we're going to give it the initial size of that constant variable. Now, something I want to point out that I'm doing here. I could just write 3 here, But generally, whenever you have a constant variable that is not going to change, it's a good idea to give it a name rather than just write the number, because it serves as a form of documentation when you give it a name. Additionally, what is the current top of my stack? Someone in chat tell me here. What will the top be when my stack is empty? I can pull the whiteboard back up. Again, we're using the purple text, not the blue text. So if that stack is empty, what is my top? Null? It's not null, because null, integers can't be null. But there we go, exactly, it's 0. Perfect. So we're going to say top equals 0, exactly. From there, we're basically done with the constructor. Now, the next thing I need to do is I need to say, okay, how am I going to add a item to this stack? So let's take a look. Let's go back over to the whiteboard and let's just draw it real quick and let's see what variables change. So let's say that I'm adding, and I'm going to remove the top over here. Let's say that I am adding, where'd my eraser go? Oh well, here it is. Let's say that we're adding to the top, and I'm going to push the value 7. So in this case, and granted I'm using ints, not strings, but the principle's the same. Stack is an array. How do you change the size? Well, we're going to get there. Great question. I'm glad you're asking that. We are definitely going to get there. So for now, I'm going to drop 7, and 7 will appear at index 2. What is unique about index 2? Index 2 is the index of my top variable. So I can illustrate this by saying whatever my new value is, my array top is going to be set equal to whatever that value is. Call it x. So that's the first step. But then I need to make one other change. What change do I need to make? Think about it for a second. Is top valid still? No, exactly. Top plus equals 1. I need to increment top. So that way top is now 3, because that is my first empty space. If I add another value, it's going to go in here. So now let's actually translate this into code. So we're going to push the value, the stack, which is the name of my array, at top is going to be equal to s, the string I'm pushing. Then I'm going to do top plus plus. Now you may be thinking, what if we run out of space? We're going to get there in a bit. For now, let's just start with this. This is all we have to do. It's fairly simple. From there, how do we pop? So popping means removing, and this is actually 2 steps. The first step is to remove the element, but the second is actually to return it. We want to return the number 7 in this case. So let's go back to the whiteboard. Let's illustrate how we're going to pop. So when we pop, keep leaving my eraser and marker over here. When we pop, I'm going to remove the 7 from this stack, but I want to store it somewhere. So I'm going to create a temporary box to hold that 7. I'm going to reach down, pull the 7 off the top of the stack, and drop it into this box. And let's call this box out. So it's a variable that will store that value. I am then going to say what to top. What am I going to change? I thought we were... Sorry about that. Top minus minus, exactly. We're going to subtract from the top. So top is now 2. Now at this point, you may be thinking a question. And that question is, what about this 7? Do we need to delete this? The thing about arrays is this. An array of integers cannot have a null value. It can't have an empty value. So something has to be there. We could change it to 0, but really we don't need to do anything. The reason we don't need to delete that 7 is this. What happens if I were to push the number 5? What on that stack would change if I pushed 5 right now? Right. The 7 would be overwritten by the 5. If I pushed 5 right now, we would say or stack top, which is 2, equals 5, and it would delete that 7 and put 5. So effectively, this 7, it makes no difference if it were 7 or if it were 0 or if it were anything. So because anytime we would push, we would overwrite that, we don't actually need to delete this. So the only steps that we need to do, now are, first, we're going to store our output, string s, or string out, equals the stack top. This is storing our output so we can return it later. We're then going to say top minus minus to move our top pointer. And then finally, we return out. We return that string that we saved. Any questions so far? Just chatting. Well, so that's a category. It's called IRL. It used to be called IRL. It's now just chatting, and that's because I had to give it some category. Doesn't mean if. So if I print the. So the question was, and this is a great question. If I printed the stack, would 7 still be there? So the first thing to acknowledge is we decide how the stack prints. Because by default, when we print an array in Java, it's just going to. I mean, I'll show you this right now. If I print an array in Java, int a equals 867 system.out.println a. It doesn't actually print the array, remember? It prints, and I'll just show this real quick. I actually have another problem here that we'll get to in a second. But this is what printed. This bracket I at memory address. And so what happened was we decide how it prints, so we can choose not to print the 7 because we don't think of it as on our stack. So why did I do that method just a little more? The idea is so pushing is adding to the stack, popping is removing from the stack. So we can't remove anything from an array. We can just, we could set it to 0 or we could set it to another value. But my point here is we don't need to. What about pop for an empty stack? Great question, I am Ramsey8. Fantastic question. Because he or she asked the question that you should be asking, which is, what do you do when the stack is empty? And so, you remember those exceptions we talked about last time? I'm going to use one here. If top equals 0, which this means our stack is empty, I'm going to throw illegal state exception. Error, cannot pop from empty stack. So this will crash the program if you try to pop from a stack. If the top is always one ahead, shouldn't you top before? So I am storing. Oh, that's correct. No, thank you for that. You are exactly right, Bob Sherman. Thank you for catching that. You are exactly correct. Should actually be top -1 in this case. Thank you for catching that. Why return out? So the point is, when I pop off this stack, let me switch to the whiteboard real quick. When I pop off this stack, what I want to know is what value have I removed. So I actually want to, going back to our initial setup, I don't just want to remove a value, I want to know what value I removed. And so as a result of this, I need to store this 7 because, well, and technically I don't need to store it the way we're implementing this, but when we get to linked list, doing it this way will be helpful, as we'll talk about linked lists much later. Also, yes, my face is covered up here by that, sorry. So then we store that value We then do top minus minus. We then return 7 because we need to know what value to remove. So now at this point, while in memory my stack looks like this, I, as a human being, am going to say that the stack doesn't have that 7 in it. I can cheat like that. And the way that I cheat is in my print stack method. So let's take a look at that. So if you notice in print stack, in this case, what I can do is instead of looping the length of the stack, I can just say while I is less than or equal to top. Or in this case, since I don't actually want top, I can just say I less than top. So what I'm going to do is I'm going to loop through and I'm going to print my stack one value at a time, but I'm going to stop when I equals top. That is to say, I'm not going to do it. Should we throw an error message for pushing out of bounds as well? That's a great question, Jules. And the answer is actually no. And we'll talk about why I say no in a second. Thank you, by the way, Runaway Trains, for answering that question. Yeah, so stacks are used in something called recursion very heavily, and that will be something we talk about after algorithms. So the question is, what do we do to prevent ourselves from going out of bounds when we push? And I'll get there. So now we're actually, well, let's just go straight there. So let's go back to the whiteboard. And let's say that for now, my stack, just like the one we created here in class, has a max size of 3. Where did my purple marker go? There it is. Sorry about this. So this is the max size of the array. So what happens if this is full and we try to push? Take care. What we're going to do is we're going to say, okay, this stack is not big enough, so let's build a bigger stack. How much bigger? Let's say twice as big. So I'm going to, and let me just erase some of this I don't need anymore. I'm going to create, so let's remember our variables. In this case, top equals 3. Our variable, the stack, is the address of this array. I'm going to create another array of size 6, twice as big. I am then going to loop through this array one step at a time, so I equals 0, and I'm going to call this my new stack. And for this new stack, I will say new stack I equals the stack I. Copy the value over. Increment I, do it again. Copy 6 over. Increment I, do it again. This process is called grow if necessary. If I need to push and I'm out of space, I'm going to double the size of the array. I'm going to copy all the values over one at a time. And then the last step is I'm going to change the stack to be pointing instead to this new, bigger array. This now allows me to push, because notice I can push 3 more values. What happens when I push 3 more and I still need more space? I repeat this process and make a stack of 12. That's the idea. This is grow if necessary. Is the topmost the it could be either. So for this case, I am using the first unoccupied value. Exactly. So great. So Mo Mike Mo problem. So you create a new array and copy the values. Exactly. So let's do that. Well, it turns out I've actually already hang on. Did I spell? Oh, throw new. Sorry. So I've actually already written this code. So the first thing I'm going to say is if top equals stack.length, we're going to grow. So we create a new stack that is twice the size. We then copy. This copies old to new. We copy all the values from the old stack to the new stack. We then change the pointer. So this is the part where on the whiteboard we went from saying that the stack on the right is now that variable now points to the stack on the left. That's what that highlighted line of code does. And by the way, you can use an array list for this. Exactly right. And then I have a print for growing. This is just to show you when it's called, as we're going to do a test with this in a second. But this is the step. So now the next thing I need to do when I push is I have to say, where does the size twice come from? It comes from right here. I choose twice the size. There's algorithmic reasons for this, and it has to do with something called amortized analysis, which sounds complicated because it is, so we're just going to skip it. But so now, pardon me, I'm going to go back to push, and I'm going to add one thing. I'm going to add the line grow if necessary. And this calls this line of code. Now, I want to be clear, this function is private. This is not part of the stack's interface. A user using the stack will never call this function. Rather, if they call push and the stack is out of space, grow if necessary will be executed for them. So this makes sure that we never run out of room. So now I run this program. We take a look at our stack, and you can see that we push Nada, we push Lorna, we push Jennifer, and then when we push Daryl, you'll notice that we get this growing message which came from grow if necessary. There's no reason we need this, by the way. This is just for class illustration purposes. If I were actually giving you this code, I would comment this out because I wouldn't want to see this. This is like a debug message. But just so that way you saw that this function got called, there's growing, and then now notice we have enough space. From there, we keep popping, until eventually we try to pop. So notice as we go through, we pop in reverse order. So Daryl was the last thing on the stack. It's the first removed. Jennifer was the next thing on the stack. Next removed. Lorna, Nada. And then when we try to pop again, which we do down here, we get that illegal state exception because we're out of space. Or we're out of values to pop. So we can't do any more popping at this point. And you may think, well, why are we crashing? It's so that way, and we talked about last time, the idea that it's having a large one. So great question, CFT. So the idea here is we want to design our code such that it can't be used incorrectly. If the user tries to use it incorrectly, their program will crash. Question is a large stack size detrimental? It's a trade-off between memory and time. You can make a very, very large stack initially, and if you're going to push a lot of values, that would be advisable. But if you're only going to push 3 values, you're going to end up allocating a ton of space for an array that you're not going to use. The nice thing about starting small and growing when necessary is that it turns out that adding still on average takes constant time, and we'll talk about what that means over the coming week, but suffice to say it's fast enough on the aggregate. So that tends to be the way these things are done. Why not just make a new array of size 1 rather than double it? So one reason is because this process, notice that grow if necessary involves a loop. And this is the problem, because what if, let's say I have a stack that has 1 million elements. And then if I add only one space and I push, so now I have 1,000,001, the next time I push, I have to copy another 1,000,001 values after I just copied 1 million values. So to add 2 values, I had to copy 2,000,001 values. By extension, if I double every time, each time I need to call grow if necessary gets exponentially more and more rare, which is why the trade-off is there. If we get time, I'll do some not class-related material on amortized analysis to show you why doubling makes this average out to something called constant time as opposed to linear time, which is good. Is the grow if necessary property true for all stacks? So you can have stacks that are limited size, and for example, all stacks are ultimately limited by the size of the memory. For example, if I run out of memory, I can't allocate any more memory for an array. I'm going to get what's called a stack overflow error. That stack has nothing to do with the class. It has to do with the Java memory itself, or it would be an out of memory error would also be possible. So why was no, that you're thinking of a queue. So the question by Rowan Osman, that is a queue. So a queue is first in, first out. A stack is first in, last out. All right. For the sake of time, I'm going to move on. If there are more questions, I'll stick around at the end of class to ask them. But we have an entirely new concept to cover, which is queues. So with queues, excuse me, I'm having issues switching here. There we go. So with a queue, the difference between a stack and a queue is instead of the first in, last out, it's first in, first out. So let's go over to the whiteboard. And with a queue, and actually my queue in the code is size 4. With a queue, the idea is we're going to have a head that is a starting point, the front of our queue, the front of our line, and then we're going to have a tail, the back of our line. So let's say right now my queue were something like 8, 6, 7. This value is the head. And like in the last example, we're going to say tail. Actually, let me for now make this bigger just so I can illustrate a bit better. Tail is going to be the first empty space, just like with the stack. Correct, David, correct. So from there, so this is like your office hour queue. This is the first person in line's the first person helped. So if someone joins the queue, what they're going to do, so if I add the number 5, I'm going to add it to the tail, and then I'm going to increment the tail. Now, what I could do if I wanted to, and I'm not going to do it this way for the reason I'll explain, is I could say if I want to remove from the head, what I could do is replace 8 with 6, and then replace 7 with, or 6 with 7, and 7 with 5. And I could shift every value over. But the thing is, again, imagine my queue were, say, size 1,000,000. I had 1,000,000 things queued up. I have to shift 1,000,000 values to do that. So I don't want to do this. Instead, I'm going to do something, and this technique is often called a ring buffer. Ring, R-I-N-G, buffer. And instead, I'm going to remove head by simply saying head plus plus. So this is my starting point. If I in-queue a value, that is I add a value, I add it 3, I increment the tail, and if I remove a value, I increment the head. Now remember, just like in a stack, I don't need to delete this 8 and 6 because they'll get overwritten eventually. The problem that you're probably already thinking of is the fact that this array still has a front and a back, and I'm going to run out of space, aren't I? Well, the key is to visualize, and I'm going to draw this in blue so that way it's clear. That's not a smiley face, that's an arrow. Visualize this queue instead as a ring. And I know my artistic skills are just so amazing. Index 0, 1, 2, 3, 4, and 5. And so the thing is, what value is after 5 in the array? Well, there's nothing. But what value is after 5 in my ring buffer? Well, it's 0. So you think of this as round. And so as a result, when we push onto the tail here, it's 5, 3, 0. Sorry, I'm remembering the Jenny I Got Your Number song. I'm going to push O, but then my tail, rather than being 6, which doesn't exist, instead it's going to be 0. It's going to wrap around back to the front. So now my tail is 0. So if I push a value, it's going to overwrite that 8. I see a question. Let me try to answer it. Q cannot be created using an array list. It absolutely can, because anything created with an array can be created with an array list. You just have to implement these features manually yourself. Keep in mind, an array list is an array. They're actually, all it is, it's an array with a nice interface. By the way, array list has a grow if necessary function. If you have too many values that exceed the space, would you then have to create a new list then? Yes, so it's exactly the same as a stack, where we would have another grow if necessary function, where if we run out of space, we would expand. So for example, 309, I'm going to push 9. My tail increments. There is no other number in the song, so let's just do -1. And now notice my head and tail are point the same value. And the size of this queue is full. So when this happens, now I can no longer push without expanding the size. But we can do exactly what we did before. Just create a new array that is double the size. And I'm obviously not going to do this whole thing. Let's see. So now we have this is size 12. And then from there, we can do a couple different tricks to copy. Rather than copy 0 to 0, though, because we want the front of this array to be the head, I'm actually going to start from the head, and I'm going to copy the head to the first index, 7, then 5, then 3, 0, 9, -1. I will then say head is 0, and tail is, in this case, 6, or the size of my queue. So that's how I would grow if necessary, and then from there I can add more numbers again. Thank you, by the way, Runaway Trains, for helping answering. What's the application of a circular queue compared to a linear? The reason that we would have a circular queue is it's more efficient, because as I said before, otherwise we have to shift every value every time we dequeue, and computationally that would be something called linear, which we'll talk about on Wednesday. Linear means the size of your input is the size of the runtime proportionally. We want constant time, which is it doesn't matter how big our queue is, it will always take the same number of steps. Or on average, will take the same number of steps, because as you said, grow if necessary is linear, but it gets exponentially rarer and rarer. Again, if people want me to talk about amortized analysis, I'll do that outside of the usual class time. I'll try to set up something to discuss it. Anyway, so from there, let's go ahead. Let's go back to our queue, and let's go ahead and implement it. So elements equals new string, and we're going to do initial size. Then my current size, when I'm first creating this queue, equals 0, because it is a I haven't added anything yet, so it's initially 0. It comes out of the box empty. Head equals 0 and tail equals 0. From there, when I add a value, again, without worrying about wraparound yet, I would do tail plus plus. But I would, before I do that, do elements tail equals s. So we store the value at position tail, then we increment tail. Again, we'll get to the wraparound in a second. Remove, we simply store the value currently at head. String out equals elements head. We then increment head plus plus, and then we return out. Same as popping from a stack, we want to return the value we're removing. Just to make this simpler, I'm going to move the print queue function down below. And again, this code is already uploaded, so you don't need to write it down because it is already on Colab. So from there, let's handle wraparound. When do I need to change tail? Well, I need to change tail when, I'm just going to pull, I'm not going to walk over there, But I need to change tail when tail is equal to, after I increment it, equal to the length of the array. The length of that top array is size 6, and I need it to wrap around when tail after tail plus plus was equal to 6. Or that is the length of the array. So I'm going to do if tail equals elements dot length. So keep in mind with an array list, if we did it by just calling the add and remove zero function, it would actually be less efficient. If you wanted to implement a queue efficiently with an array list, you'd have to do all the work we're doing anyways. Keep in mind, an array list, by the way, does this exact same thing. An array list doubles in size when it runs out of space. It is implemented with an array. We'll talk about that when we get to algorithms. So it is an array. It's just, it has an interface that hides the fact that it's an array. So if tail equals elements.length, then what we're going to say is tail equals 0. This is my wrap around. It's where we go from here all the way up and around to here. Similarly, we need to do the same thing with our remove. So if head equals elements.length, because the head can wrap around exactly like tail, head equals 0. Now, we need to, of course, address the fact, grow if necessary. So again, I'm going to add, whenever I add, I'm going to call grow if necessary. And the process I showed is just outlined in this code. For the sake of time, I'm not going to work through it because we are approaching 12:50 and I don't want this lecture in too long. But if people have questions about the code, like I said, I'm going to stick around for, say, 10 minutes after lecture and answer them before my office hours. So you can certainly ask then. But fundamentally, it's the same idea. The only difference, and I do want to show this on the whiteboard, is when we copied to the new array, we didn't start from 0, rather we started from head. Because remember, this is not the start of our queue. Head is the start of our queue. So we're going to start from head, which is 7 is the first value, and we're going to copy that first. Then 5, 3, 0, 9, -1, and then this is the space for new values. All right, so from there, quickly just want to pull up today's in-class activity. Give me 1 second to do that. Sorry, it's taking just a little bit of a second. So today we have an in-class activity for stacks and queues. It is due, and I just to make clear, we've changed the deadlines of these. This is going to be due actually at 6 a.m. tomorrow Eastern. And the reason that we're using 6 a.m. tomorrow is just because we recognize there are people in different time zones internationally that will have a hard time. Sorry, I have the wrong screen up. That will have a hard time. This is not to encourage you to stay up all night working on this, because you shouldn't. But yeah. Do head and tail refer to index values? Yes, they are. So remember, the head and tail are ints. This means that while I'm using arrows to draw them, so going back to the whiteboard, while head and tail are pointing to index 2, that means head the int equals 2 and tail the int equals 2. It's not really a pointer. I just refer to it that way when the values are actually just the indices stored, because it's useful to think of it in those memes. All right. So with that, go ahead. I will pull up the in-class activity directions. You can go ahead and get started. Remember, with the in-class activity, unlike homework, collaboration's encouraged. Looking at each other's code's encouraged. The same is true in lab. There's no problem with that. The only rule is don't do that on the homework. Don't do that on the exams when we get to the exams. But you are encouraged to work with each other. Why would you even bother to add elements before the add to increased size to the increased size array? So the reason is those elements, going back, those elements 9 and -1 are still in the queue, because remember, head defines the start of the queue, tail defines the end. So 9 and -1 there are still in the queue before we increase the size, so they need to still be in after we increase the size. Good question. We can't just drop 9 and -1 from the queue because we expanded it. Any other questions? Where can we find your sample code? It is available on Colab. If you go on the Colab page to resources, which is right here, you'll find, you'll start here, Java code examples. My last name's McBurney, so section 001 McBurney. From there, I have everything sorted by date, so today's March 23, so there it is. No, March, sorry. Sorry, that wasn't related to this. Yeah, so Illuminati. The head is at well, the head is not at 7. The head is pointing to the value 7. But remember, the head is the front. The tail is the back. So you think of everything from, hang on, let me do it because it's mirrored perspective. From the head to the tail, everything between the two. So, just to clarify this, the Q, and I'm using my blue marker for this, goes from here, wraps around to here. And that's because it goes from head to tail. So that means that 9 and -1 are part of it. Because remember, the idea is we're treating this array like it were circular. And so the idea is the head points clockwise and the tail points counterclockwise. And everything between the head and the tail is part of the queue. Also, by the way, my slides, such as I use them, which by this point you've learned, I never like teaching with slides. So I don't use them a lot. But that said, I do have my slides up. If you go to slides in class material, you can find them here as well, 323 stacks and queues. So can I change the names for the in-class assignments since they're the same names? You're welcome to do so, sure. Why wouldn't you use modulus to handle wraparound? You can use modulus to handle wraparound. I mean, I could just as easily say, instead of this if statement, and I'm not going to really explain why this works, just show it to you. I could also do the following. Tail equals tail mod elements dot length. I could do that, and that would be fine as well. Oh, sorry. Thank you for catching that. Here we go. I could also do this. These two sections of code effectively would do the same thing. So that's why I can use modulus. In the in-class activity, it's asked to use an add remove functions the same as push pop. So with a stack, we call them typically push and pop, but you can call them add remove. There's not a problem with that. And then for a queue, we call them either add and remove or in queue and dequeue. Sometimes you'll still see push and pop for queues, but I tend to not like that terminology. Any other questions, including logistics questions at this point? Logistics for the class. So what you need to do, Big Burrito, is you need to add either call print q, or you would need to add a toString method. Because remember that when we print an object, if we don't have a toString method, it prints the name of the class at the memory address. That's why you're seeing q at a hexadecimal value. But you can just call print q if you want to print it. Do labs need to be 100% correct to get credit? It varies from lab to lab. Simpler labs, yes. More difficult labs, not necessarily. But that said, you should strive for correctness. To that end, if you need help, pop in the Discord channel. So stack at the very bottom of the white... so keep in mind that's not a stack, that's a queue. So in this case, so remember, David, 7 is the oldest value on the queue. Uh, I added 8 and 6 before I added 7, but so where 9 and -1 now are, that used to be 8 and 6, but because I removed 2 values, 8 and 6 are gone. So 7 actually is the oldest value. That is the value that has been in the queue the longest of all the values on the board. So yes, it would be the first removed, even though it was the third added because I already removed the first 2 values. Where can we find for the info for the lab Discord? That is on the Piazza master thread. So just to show this again, let me make sure I'm in the not showing any private questions here. There we go. So on the lab, we have this master thread. It's the third pin post. So COVID-19 online course master thread. And you will find here that our lab information is right here under lab changes, and here's the Discord link, so it's clickable. I don't want to keep it on the screen too long just because I know there are some people watching who aren't in our class. But it's on the master thread on the Piazza topic. 9 and -1 weren't removed. 9 and -1 were added after we added so we added in order 8, 6, 7, 5, 3, 0. We then removed 8 and 6. We then added 9 and -1. So that's why tail. See, if we had stopped adding after 0, tail would be 0. But we added 2 more values. So when we added 9, tail incremented. And then when we added -1, tail incremented. So we added 9 and -1 after we added 0. Why is there a college class on Twitch? Because I don't like using Zoom. Because Zoom sucks. Also, I have 200 students in my section. So that's why. Zoom is too hard to manage when people can forget to mute their mic or forget to turn off their camera, and it just causes a lot of problems. Any other questions? And I don't like doing pre-recorded lectures because then I can't answer questions. And as people gather, I really like that. Go back to the print queue method, please. Okay, so it is uploaded here, but here it is. Just to illustrate what this does, this prints, the way it prints the queue is a bit weird. If you wanted to print from head to tail, you would change this for loop to say I equals head, and then I less than length plus head minus tail, and it would be some complex logic, but you could make it work if you wanted. Let me remind myself when my office hours start because I can't stream. Sorry, I'm starting up Discord here, which, is a great way to handle office hours. Can you go over the add method of queue? Not more than I have. So again, these two things, this and this, do the same thing. The idea is first, if we're out of space, and I apologize for the Discord pings. I had to pull up to check my office hour schedule. We grow if we're out of space. This method doesn't do anything if we're not out of space. From there, we insert the value at tail. We then increment tail. And then if tail is past the end of the array, because keep in mind, the idea is we're wrapping around. So if tail equals elements.length, that means we've gone out of bounds to the right. We're going to cycle all the way back to the left. This is the method I mentioned before. I didn't go over it in heavy detail, but this code's uploaded if you want to take a look at it. I did illustrate it. So if you look at the bottom, that was me illustrating the grow if necessary. Oh, no worries. Yeah, this is also what I would encourage is you, because I will always upload my code before class. Once you see that starting screen, go ahead and download the code for today. That way you can follow along, just because I can't always scroll up and down as much as people would want. All right. Yeah, just to be clear, those are just two different ways. Skim milk, those are just two different ways to do the same thing. So rather than doing this, I could use a modulus operation. All right. I got to cut it off there, but I do have office hours if you have questions. Come by. Otherwise, thank you, everyone, for watching. Thank you for being here. Keep washing those hands. Stay home. Don't travel. It's going to get bad this week. We're hitting the curve of the exponential growth, and so just be cognizant of that and try to stay safe. Take care.